Okay, so this is our last lecture on file system interfaces, and this is a very small lecture where we just wanted to finish cover a couple of things. And this recording is in lieu of the missing class on Friday due to the holiday. So let's start this very small lecture with a clarification about one of the things we discussed in the last lecture. Recall that in an acyclic graph directory structure, we can have directories which share files using links, right? And now we talked about these links abstractly so far. However, from an implementation point of view, these links can be of two kinds: hard links and soft links. So that these links essentially are meant to share files between multiple users. So if I want to um, share assignment.c with you, then I'll just create a link from assignment.c which you can access. That's it. However, these links can be of two types, and first is hard link. So hard links are linked to an actual file blocks the data in the disk. And you can use the command ln and then file name and then link name in file name and then link name in Linux to actually find to create the hard links. Now, hard links are sometimes constant because they cannot link to directories. They can only link the actual data blocks of a file. What is the advantage of a hard link? It will always refer to the source file because it is pointing to the data block on disk. So even if the file's name change or if it is moved to another directory, hard links will always point to the source file. On the other hand, soft links are symbolic link to the path where the file is stored. It does not point to the actual data blocks on disk. So you can create a soft link using the flag s with the ln command. So ln minus f is the file name and then link name. The soft links can actually link directories. That means that if whoever using Windows or even in Ubuntu, you can create a shortcut of a directory to your desktop or something. All of these are basically soft links. But what does soft links constitute? Is a symbolic links, meaning that it basically contains the path where the file is stored. So if the file is moved or if a file is renamed or a directory is renamed which is linked, then soft links are destroyed. They cannot be used anymore. So hard links and soft links both exist and both of them have some pros and cons. And these links, both hard links and soft links are used in acyclic graph directory structure or even the general graph directory structure. Okay, so the rest of the things in file system interface are just two very small concepts but very important ones: the file system mounting and file system protection. Just as a file must be opened before it is used, like you call like open and then file name and then w or r in C or in Python even also. Just like that, a file system must be mounted before it can be available to processes on the system. So let's talk about what is mounting. So remember that a directory structure may be built out of multiple volumes. What does it mean? Meaning, say your computer has a 1 terabyte hard disk, internal hard disk, and now you want to connect a 500 GB external hard disk. Now your computer has a file system, evidently, like your laptop or your desktop. But the your 500 GB this hard disk, it also has a file system. It has its own directories and subdirectories, it has own files and all these other things, right? So when you are connecting your external hard drive to your laptop, There has to be an unified directory structure that comprises both that contains both your computer's file structure, like all the directories and files, and also the new hard disk directories and files. So essentially, this directory structure, when you are adding this hard drive, 500 GB hard drive via USB, for example, to your computer, to your machine, the file system in the 500 GB hard drive must be mounted to make all the files available to within the file system namespace. So what is mounting? The mounting procedure is straightforward. Essentially, when you're trying to mount the file system in the 500 GB hard drive, the external hard drive, the operating system is given the name of the device, that is your hard drive in this case, and the mount point. What is the mount point? The location within the existing file structure on your laptop or on your desktop where the new file system is to be attached. Some operating systems require that a file system type should also be provided, like whether it is journal FS, which we'll talk about later, or whether it is NTFS or it is FAT and so on. We'll talk all of this. So there are different types of file system, and sometimes the mounting requires that you need to tell the type of the file system. But in other cases, other operating systems are smarter. They inspect the file structure of the device and determine the type of file system. Typically, you mount a new file system like one in this external hard drive in an empty directory. Let's take an example. So you have in your computer, you have the following file system which is shown in A. So you have this users from root, you have this users and then Bill and then Fred and then help. They are basically your they're essentially your subdirectories. Underscore. You have Fred and then Bill, and then you have within Fred there is subdirectories help. And now this is essentially your new file system shown in B, which is basically this resides in your in an external hard drive. It has directories like Sue and Jen and then Prog and Doc and so on. And this is unmounted. So this is just this file system just resides on an external hard drive which is not connected to your computer. So when you try to mount it, what do you do? Say you want to mount it here. So what does it mean? It means that finally your directory structure will look like this after mounting. So figure in this slide shows the effect of mounting of the volume. So this is your final directory structure. And the mounting happened here. Okay. Now, if you unmount it, what would happen? Well, this part will be removed, and the original file system will be restored. So this is more like a plug and play. When you are adding your hard drive to your computer, essentially the mounting process happens that sometimes you can use the mount command. If sometimes when the file system is not detected by your operating system, or in general operating system does it automatically. But in either way, essentially a particular the file system is mounted in an empty directory, and finally the whole directory structure contains the index to all the files both in internal hard drive and external hard drive. So this is your mount. Now lastly, let's talk about the security of file system, or rather how to protect files from unauthorized access. Now, when information is stored in a computer system, we want to keep it safe from improper access, which is basically the issue of protection. To ensure also what is ensuring protection? So for ensuring protection, a file owner or creator should be able to control like what operations can be done on a file, like reading or writing, and by whom it can be done. So what do we mean by operation in this case? Essentially, operations can be reading a file, writing a file, executing a file, appending to a file, like adding more information at the end of the file. Essentially, that means that is appending, or deleting a file, or even listing the name and attribute of a file. The question here is that who should be able to use all this given a file, who should be able to do all these operations use on a file. So the most common approach for this ensuring protection, like I want student A to read a file, on the other hand I want the TAs to write to a file, right? And the most common approach for ensuring like only few people can do few operations, this or protecting this file, is to make access dependent on the identity of the user. So each file in general contains three mode of access: reading, writing, and executing. These are three types of operations: reading a file, writing a file, executing a file. It also contains who can read, which user can read the file, which user can write the files, and which user can execute the file. This is your access control model. You're controlling access. Now, in Unix or even Linux, to condense the length of this access control list, like who can be able to read, who can be able to write, and who can be able to execute, essentially in a system there might be thousands or infinite number of users, and doing infinite number of and specifying for each of the user who can read, write, or execute, if that actually is computationally expensive. You need to enlist stage enlist the whole thing, and during each file access you need to check against that list. So rather, in Linux they actually condense all of these users into two groups, right? So owner is for a file, owner is the user who created that file. Group is a set of users who need similar access to the file, meaning all the students, for example, might need read access to the question paper. On the other hand, the instructor like me needs write access to the question paper, me and SG. So me and SG are in a group, all of you is another different group. So it requires similar access to the file. What is public? Who is neither in owner nor in group, they're all public. For each of these categories of users, what happens is that in Linux, each file for each of these categories of users contains 3 bits: one for reading, one for writing, and one for execution. Reading is R, writing is W, execution is X. So in this case, let's take a file. Okay, let's take the example. One file. So the owner access the RWX might be, and each one of them 1 bit. So 111, meaning the read owner can read, write, and execute. For a group, that means in this file, that if the group specified, the group that owns this file, the group that can access this file, the group members can do read and write but cannot execute. And the public cannot read, cannot write, but can execute. In other words, it becomes 7, 6, and 1. 111 RWX. That actually means, like in binary, 111 means 2 power 3 minus 1, 7. And then 110 in binary, if you convert it to decimal, is 6, then 1. Say, you can actually use this is chmod command to specify these accesses. So what if this owner access? So there are interesting questions. For example, that if you make it 011, that is essentially 3 and then 6 1, what would happen? If it is 0 1 1, that means the owner cannot read. That basically that means the owner will lose access to the file. That happens sometimes. So essentially these three groups, these three entities, owner, group, and public, is used in Linux for each file, and for each file it is specified what the owner can do out of read, write, and execute, what the group can do for read, write, and execute, what the public can do for read, write, and execute. So here in this particular case, right, if you run this command chmod 761 and this is the file name, say this is the file name game, that means that the owner can read, write, and execute the file game. The group which has like the group who can access game, they can access but they can only read or write but cannot execute, and in other public can execute. Now when we're talking about these groups, right, in Linux you can attach a group, one group, to a file using this command chgrp, change group. Say here you create a group G in Linux, the, and like assume that there is an existing group G. It's pretty easy to create. There are comments for that, and then you will just run this command ch group G game, so that it means that game should be accessed by the group members of group G, and all the members of group G has the access 6. 6 means RWX110, meaning read, write, but do not execute. So if you want to take, this is a just an example of whatever we just talked about now, about RWX page and owner and group permission and public permission. So you can see the result in ls-l in a directory. The first column basically shows the exact permission grades that we just talked about. So it basically have the first bit here is either D or a dash. D means directory, dash means a file. So intro.ps is a file. So first one is dash. Private is a folder, a directory again, a subdirectory, subfolder. So there is a D. And then you have RWX. RWX, RWX. So if you do ls-l, the first RWX, what that is? So this 3 means that the owner can read, he can write, and but he cannot execute. What about the group? The group can read and write but cannot execute. What about the public? The public can only read but cannot write, cannot execute. So when you say no, then this dashes means that you cannot read and write. So RWX are the 3 things. Okay, great. So how do you know the group name? The group name is here, staff. Staff is a group name. Now, here is a question, homework question even. What is the meaning of chmod 777, 644, and 700? All three are important. Meaning that 777, I'll just give one hint. 777 means RWX, RWX, RWX. Everything is one. Meaning the owner of the file can read, write, execute. The group of the file can read, write, execute. The public can read, write, execute. It's also called word accessible. Think about what it means to chmod 644 and chmod 700. If you want to know more about these file permissions and more clarification, please check With this, we finish our exploration of file system interfaces. We'll start with the file system implementation from next class onwards.